Markus, das wird heute eine Privatfolge. To today's .NET Meetup, our August 2022 Meetup. Thank you all for joining today here in person, also remote on stream. We who are organizing the meetups, .NET Devs Austria. We are a non-profit organization here in Vienna that do it. We have a website, we have Twitter, Twitch, YouTube, and Slack. You probably know it already, and you should get the links in the chat now. I also want to thank our sponsors, Rubicon, Theater Every, and JetBrains. Rubicon and Theater Every support us financially that we can do these meetups and have the hardware for streaming and our streaming solution. JetBrains supports us with a 12-month product license that we can raffle, that we're raffling today here. Again in person, and yeah, thanks to our sponsors. Some quick news from the community. We're part of the .NET Foundation. They have a .NET Foundation virtual user group. If you need more .NET content, go there, join there, have a look at it. And a lot of meetup groups around the world are announcing their meetups there, and yeah, have a lot of content to watch there. New section is some recommended .NET content creators from us is, so the first is our own Stefan Flashware. He streams every Sunday from 9 to 11 Central European summertime. And the topic of the streams are currently performance benchmarking of source generators. I have to watch some recordings of it. I'm really curious how to do this stuff. Then we highly recommend Claudio Bernasconi. He's a content creator from Switzerland. Has a lot of beginner content, .NET beginner content. You should get the links in the chat. And the third one is, perhaps you know it, is Nick Chapsas, a .NET content creator from United Kingdom, and he has a lot of various .NET related topics. He's a big fan of minimal APIs. Good. And that was it. And with the intro, and today we are running an experiment. Experiment has an outcome. Today we wanted to have some lightning talks, and we have 2 lightning talks. The first is from me. It's about what I do when I create a new project before I do anything else. I want to show you that, and it gives perhaps you don't know, it gives you some tips what I'm doing. And the second one is by our Stefan about mutation testing. I'm very curious about it. Good. And with that, I'm switching to my notebook and switch to my Visual Studio. So you see here the Visual Studio, you see the Visual Studio on stream. Cool. So no slides, nothing, lightning talk, 10 minutes, and that was it. So what I have here is simply a Visual Studio file, new project, console application, when Visual Studio loads. Console app for .NET 6. And build this, and we run this. We have our normal Hello World console application. Open it, we have here programs, yes, and everything. So, but I adjusted this all with the stuff what I do first when I create the project as a setup, simply to it makes some parts easier, some parts automatically for me, and if I makes some changes at the end easier. The first thing what I do is, perhaps already a little bit high level, is creating files that are called directory.buildProps and directory.buildTargets. And these are located in the solution folder on the same level as the solution file. And what happens here is that MS Build, the build engine, automatically imports these files and gets properties. And you can set various project properties or so via these files, and this enables a lot of stuff, and I'll explain every line here in a moment. And in MS Build, there are the props file for properties and item groups for setting, and there are also targets where you can adjust more the build pipeline. This is empty, but I always create both files at the same time. And what the nice thing is yeah, this file is imported by every project. So if I create a new project, all the stuff what is defined here applies also to the new one, or the class libraries and so on. What do I set here? I generally set here in these property groups. We have this also when you open the CS profile. You see some of them. Some of the properties what are defined is lang version, and this defines which language version of, in that case, C# should be used. This is now set to latest. And what I had project where I needed to set for specific reasons, because I had to target .NET Framework and .NET Core. I couldn't use all the language features, so we said, okay, we only want language feature until C# 8. And to not have to go in every project and set this manually for every project, you can do this in properties, build, and somewhere in this long list, language version. This is not grayed out because you find it somewhere else. To not do this, you can put it in the directory build props and define it for your whole solution, for all projects in the folder structure. The same, and this is for all these properties. The second one here is nullable. This enables nullable reference types. So with your exclamation mark and question mark, the language feature. The third one, that's for me an important one, personally something I want to take more focus on. Treat warnings as errors, that all my build warnings are real errors. And yeah, to have it simply clean and don't get over time 200, 300 warnings in the code. And yeah, these three properties are normal, they are automatically applied to all. The next one, the fourth one, is a little bit special. It's a custom MS Build property. I call it Project Target Framework. And you probably were in the situation, you have your project, you have 15, 20 projects in it, but then a new .NET version came up and you want to update it, and you go to 20 projects and switch everywhere the target framework. In the old .NET Framework times, this needed to be mostly done manually, because Visual Studio Magic also had. Now you could do it with a search and replace, but with that, now you can also define here a property group, and then in your project file, you need to do some manual editing. Here's also a property called Target Frameworks. And where now say use this variable. In the original, it's here 6. It was like this, and I simply swapped it. And now, what you can now do, let's remove all the bin folders. So we build now bin debug.NET 6, and I simply switch this to 5. Now it's downgrade, make a rebuild, and I build for .NET 5 with one small change. So not hour-long changing of projects to target the newest .NET version. Good. This was the properties, what you can normally define for every project at once. What you also can do is with the starter build props is define NuGet packages that are applied to every project. There will be, I think, in the next in the future, I don't know in which language or somewhere, a dedicated feature for solution package references. I forgot the official name, but you can do it already because this is the same thing what you have created via the NuGet dialog in your CSPROI. And what I do here is I add NerdBank Git versioning to all the project, and this does my assembly versioning based on Git. It's a cool library. I'm using it since years, and what you can do is you add NuGet package, and you have this version JSON where you define what's your version number is. So it's 0.1 beta at the moment. And then we have a look at the properties. Here it's a little bit small for you, but it's 0.1.2.62154, and this is automatically generated. And the 2 is from the commits since the last change of this version number. So if I change this to 2 and make a commit, then I'm getting assembly version straight with 0.2.1. So major, minor version are defined here. Patch is then you get this from your Git commits, and with that you have proper assembly versioning, and you can also do tags for pre-releases, and this is very, very cool feature. You can use this together. When you create the library and NuGet packages, you can also get this information into your NuGet package, and your version numbering issues are solved. What it also does is, for the case you need to access the version numbers in code. It generates some automatically code, and you can access with disassembly dot and get all the assembly version configuration file versions. So if you have a UI application you want to display somewhere the version number, you have this information already available. Yeah, and that was this. These are some small things. It's not 10 minutes if you did it twice or 3 times to set this up. But this is my skeleton project, and with that, after I did this, I then really create the application, because that's my minimal setup for this, and most of the annoying stuff is solved with that. Hope I could show you something new. Any questions? No? No? Then I hand over to Stefan. Which is also our stream operator today, so he's currently working at two notebooks at the same time.
Sorry. So, gut, du bist am Stream.
Das musst nur noch. Ja, nee, schon. Wenn nicht so geschwind.
Easy?
Yes. Plug and play. Go with it.
So. Good.
Yes, sorry. HDMI.
So, das Screen Sharing ist jetzt weg. Gut. Stefan, du bist aus dem Stream jetzt rausgeflogen.
Share screen.
Ja. So, passt.
Cool. Go. So we did made the switch somewhat fluent. Hello, thank you very much for joining. Hello online. I will talk a little bit about mutation testing, especially in .NET with C#. So what is mutation testing? We talk about the what, the why, the whens, and the hows. So mutation testing is a tool, an automated tool, which does very small modifications to our production code. And each of those changes to our production code is called a mutant. Now, the tool analyzes which tests are actually covering this mutation of the production code, and all of those impacted tests are then run. And now we expect at least one test to fail, because the input, the production code was changed. Of course, now a test should fail. So we need to have at least one test which asserts that change and expects it to be some certain way. Now it's different, and this is when a test is good, because that means if a test is failing, that means a mutant was created and it was killed. That's the term. However, if there's no test failing, this may mean that this change in the production code, this mutation, was not covered by any test, or perhaps was covered but not really asserted against. Then the mutant would survive, and this is bad. And then at the end, the result is the effectiveness of our test suite, in the percentage of how many mutants have been created and how many mutants have been killed or have survived. And the credo is in mutation testing, we must kill all the mutants. Why would we like to apply such an automated tool which changes our production code in order to test our test suite? Because in my opinion, it supports test-driven development, and there's a bit of a difference between code coverage and test effectiveness. I could write tests which cover 100%, but I may not have a single assert at the end, so you need both. Now the advantage of code coverage is super fast. There's a lot of tooling which make the TDD experience very fluid. For example, in Visual Studio, you have live unit testing in the Enterprise Edition. There's also a plugin for Visual Studio called nCrunch. You could also use the continuous testing from Rider, and for Visual Studio Code is also some combination of plugins and extensions that you can use. And then you get a very fast overview about which lines are covered. But mutation testing, the disadvantage is it's slow, but it's very thorough, because it basically expects a test to fail when a change happened. So how is this change happening? Now, I have here a bit of an example. At the top, we have our production code. This could be our library or somewhere in our application, which adds 2 numbers. Down there is the test. We call this add with 1 and 2 and expect it to be free. So with our initial test-driven development, we will first write the test and production code, test has passed. This is good. Now mutation testing has a look at this code, at the production code, and sees here something which could be mutated. So mutation testing could change this plus, this addition, to a negation. And now all the impacted tests, every test which covers this line is 1. And now we expect at least 1 test to fail. And we have here a failing test, which is good, because that means this line is not only covered, but also asserted. If I write the code wrong, a unit test fails. And then mutation testing goes on. It checks the entire production suite, various mutable statements, change, for example, a subtraction to an addition. Once the test expects it to fail. Same with multiplication, division, but also logical statements. For example, this conditional AND operation could be changed to a conditional OR. And then the test is run. Or the comparison operators, so this less than or equal to could be changed to a greater than, and then all tests are run. Important part is that each mutant is observed isolated from the other. So one mutation, we run all the tests against this very single mutation. We don't combine mutations. So this now mutation testing check language features. Mutation testing could also check BCL features. For example, in .NET, we have a link all. This could be changed into a link single, for example. No, this doesn't exist. Something else. Any, for example. Change the all to an any. And then again, we expect at least 1 test to fail. We have 1 passing and 1 is failing. So this is good. At least 1 test must fail. Tool that there is several tools in .NET. The tool that I personally like is striker.net. So for striker.net, there is also a JavaScript and a Python version. This is very recently, this is in active development, and it's a .NET tool that you can download and to run your mutations. Now, there is different methods of how mutations can be created. You either create them from the source code, that's basically what we did. You could also mutate the bytecode. Now this is faster, but the report isn't as precise as it would be when we mutate the source, because then we have the source code at our hand. And then there is somewhat, not really a combination, but a bit of a more effective way. You can do mutant schemata or mutation switching. This is what Striker does. Basically, it creates one big suite of a mutated source code, but has everything guarded with switch or with if cases, basically. And then each mutant is run with a different switch activated, so that each and every test is mutation tested, or each mutation is tested isolated from each other. I'm listing here. You can later have a look at the slides. I'm listing here some frameworks. My favorite is striker.net. And basically, it's a .NET tool that you can install. I like to install it. You can install it globally, but I like to install it locally, so that it's part of the repository. You can create a manifest, then install the tool locally, and then can go. I also link some configuration and some reporters, like a reporter is, for example, an HTML reporter or console reporter. There's also a lot of stuff you can configure. For example, that you only want to mutate the change set compared to a different branch. Like if you have a feature branch and you don't want to mutate all the source, but only what has actually changed in this feature branch to make it a bit faster. Now I want to briefly show you this thing in action. So I'm switching to wider. What I have here is a suite of unit tests. So again, I have a calculator. I add, I subtract, I multiply, I divide, and a remainder. And the calculator is implemented like here. However, there's a little bit of a bug. For the divide, we actually implemented a multiplication. So this is wrong. However, we have full code coverage. If you have a look at the gutter here, everything is green. Actually, if we have a brief look at the code coverage report, we see everything is 100% covered, everything is green. So what the mutation testing is doing, it goes ahead, changes the plus to minus what I showed earlier, and eventually comes down here, changes the multiplication to, let's say, a division in this case, or to negation, changing it to anything. And when I run the test, now we have one failing test. So although we had 100% code coverage, we still have a failing test when we change the source code. So actually, this doesn't necessarily say that the production code is bad, but at least the source code isn't, the test code isn't as effective as it could be. And if we go to the division, we see that I divide 1 by 1, which is 1. So perhaps I should add a more interesting test. If I'd say divide 10 by 5, and I expect 2. And if I change back to the original source code that I had, we will now end up with a failing test with the original source code, and now I realize, okay, there is indeed a bug, so I can fix this bug. And yeah, so what this should show is that mutation testing may unveil if the test suite isn't as effective as it could be. And since this is a lightning talk, let's come to the end. So in my opinion, mutation testing, so I showed it, the manual tooling, since the automated tooling takes a bit of time to run, because depending on the source code, there is a lot of mutation it generates and a lot of tests to be executed. In my opinion, it complements TDD because you end up with a more effective test suite. Code coverage report is only half of the story. It's good, but only part of the story. Combined with the mutation report, it's then a more complete picture. And in my opinion, it suits very well for library code. I had not so good experiences with doing it for app code. We have had some trouble getting it, for example, one with Blazor application. We still want to do that eventually. And with infrastructure as code, also, yeah, you rarely have. So you need unit tests in a term of unit test thing, and not integration tests, in order to make this viable. And the thing that you need to have a look at, depending on the tool that you're using, it heavily depends on the mutations which are available. So Striker.net is very rich, has many mutators, but if you're using a less mature project, maybe it only has a handful of mutators, then the report, not too many mutants are actually generated in the first place, and then the effectiveness is not as meaningful as if there was more mutations. And always stated, it may be long running. So we have one project in the CI pipeline, it was like 15, 20 minutes, but it gives then a very good picture on how effective our test suite is, and then eventually how good our production code is. And yeah, this is a brief overview on mutation testing and with a bit of C#.NET in it. Did I leave some questions unanswered? Cool. Then thank you very much.
Thank you, Stefan.
jetzt den Screenshot und hier anschließen. Das geht schon.
So.
Good. Thank you, Stefan, for your lightning talk. And with that, we're done with the lightning talks for today. Thank you all for joining today. Thanks to our sponsors again, Rubicon and TA2 Avery, and also JetBrains. If you want to host a meetup, please get in contact with us, and you or your company get in contact with us. We find a solution. We find a speaker. Let's talk together, and we can arrange something. Next meetups, not yet publicly announced, but we have it already for September, is modern observability for your .NET apps with open telemetry. Joao, and this is 21st of September. 20th of September is there. Announcement of Meetup.com will go out in the next days. And yeah, for October, November, still open. So if you want to speak at our meetups, please contact us. If you want to host us, please contact us. Then try that. And also, please spread the word that we're doing these monthly meetups. Invite your colleagues, friends, customers, retweet our stuff. Invite everybody that has something to do with .NET or wants to learn something about .NET. And yeah, our resources again. And last slide, we want to improve these meetups, so feedback would be very appreciated. You have the link in the chat or here as QR code, and full-time, please fill out the quick survey. It helps us to improve further meetups. And with that, we see you in September. Bye.